Hello, Chemistry 150 students. In this problem-solving session, I will be covering problem 80, part B on your chapter 4 homework. And I love this problem because it combines our understanding of net ionic equations and also gas evolution reactions, which are double displacement reactions followed by a decomposition. We'll be covering gas evolution reactions next week's videos. And this week we've been doing total ionic and net ionic. So this problem reads, write a balanced complete ionic. So we're going to write a balanced complete ionic and net ionic equation for the following reactions. Okay, so here's part B. I have ammonium chloride, which is aqueous, which means it dissolves in water. And we know that because of our solubility rules, and the ammonium ion is always soluble. We have sodium hydroxide, which is also aqueous, which means it is soluble in water, dissociates 100%. And we know that because group 1, like sodium, is always soluble. Those are those solubility rules that we covered last week and our double displacement precipitation reactions. So ammonium chloride, which is soluble, sodium hydroxide, which is soluble, produces water, which is a liquid, so that's not ions that are dissociated. Ammonium gas, again, not ions, and sodium chloride aqueous. Now, the reason why this is soluble, again, we follow our solubility rules, and again, group 1A elements are always soluble, so the sodium wants to stay by itself as an ion dissolved in water. So what do we do for the complete ionic? Any of these molecular equations that are in aqueous, we're going to separate into respective ions. So we have in the complete ionic, the ammonium ion, because it's soluble and free floating, the chloride ion, and I have to include the charge in the phases if I want to get this correct. So then I have the chloride ion, and it has a negative charge because it's group 7 halides. The sodium ion, and the hydroxide ion. And again, those charges have to be included. Sodium group 1 plus 1. Hydroxide, one of the polyatomics you need to know, has a -1 charge. Now on the product side, okay, when I look at the products, if it says solid, liquid, or gas, I do not separate into ions. I write the complete molecular formula. So water, I don't separate because it's not separated as ions. It's actually what's being produced. And then the ammonia gas, it's not separated. But if I look, this sodium chloride is aqueous, so I have to separate that. So now I have the complete ionic. This shows all of these are in solution. They're floating around. And what happens is these ions are going to come in contact. Now, and they're going to produce something. And that's what my net ionic shows me. My net ionic shows me the actual reaction. It shows what ions are combining to produce something, okay? So, but before we can figure out our net ionic, they want you to eliminate what are called spectators. The spectator ions are just floating around. They never combine with something to produce a solid, liquid, or gas. They just stay dissolved by themselves in water. And it's really easy to recognize the spectator ions because they're on both sides of the equation. So if I look, ammonium, NH4 plus, is not on my product side anywhere. Now someone might say, well, that's ammonia. Yeah, but ammonia is not ammonium. So you can't eliminate that. If I look at the chloride ion, I see that I have that actually on the product side as well. What that means is it hasn't undergone a reaction. It hasn't changed. And if there's no change in chemical composition, It's the same thing. So what does that mean? This is a spectator. It didn't do anything, didn't change. So I can eliminate it. Then I go to the sodium and I see, oh, it's also on the product side. So I can eliminate that. So I see now the only thing that remains are what's involved in the reaction. So my net ionic equation, what really produced something is the ammonium ion, and I can't forget the charge, the hydroxide ion, and they actually came together to produce water and ammonia gas. So that is really the true reaction here. It's the net ionic. So you use complete and net ionic equations with aqueous reactions. And what I mean by aqueous reactions, reactions that have ions dissolved in solution. So where do we see a lot of aqueous reactions? So some books actually give this a separate section and name in the book. Basically, your aqueous reactions are your double displacements and single displacement reactions. So I hope this helps. I hope that you enjoy this. We'll be covering more of this in week 7 with the gas evolution reactions. And thanks for watching.